Okay, now let's talk about the second part of the lesson. It is efficiency of machines. Now let's see what does it mean. Now in lesson 1 and lesson 2 of this chapter, we talked about machines and we said that machines are devices or instruments that make work easier. They help us by making work easier. So they don't change the amount of work we put into them, but they make work easier by changing force or changing distance or direction of force and so on. Okay? Now in this lesson, we want to talk about the efficiency of machines. Let's first see what's the meaning of efficiency. Efficiency is a measure of how much useful work a machine can do. So not all machines have the same amount of efficiency. Not all of them give us the same amount of useful work. Read the second sentence. Not all of the work done by machine is useful work. It is very important. Why? Because of friction and other factors, only some of the work done by a machine is applied to the task at hand. There is a difference between the total work and the useful work done by a machine. What does it mean? Let's look at this example to understand the meaning of efficiency. Here we have a simple machine. What's the name of the simple machine? It is a pulley. Okay, so this is a pulley. We use it to raise object toward up. Okay, so in this example, we put input force here or the input work. So the input work is here. This is the total work. So this is the total work that I will put it on the machine by my hand. Okay, so we call it input work or total work. Now this work will directly transfer to this side to raise this object toward up. This work that is here, we call it useful work or output work. Now, before we said that machines, they don't change the amount of work. That's true. So if here it's 10 joules of work, here 10 joules of work. 5 joules, 5 joules. But in real life, what do we have? We have friction. Friction causes what? When two objects are in contact. What happens? Heat. And heat is a type of energy. So, because of friction, we have heat. And also there's another thing. When you're using a pulley, what you're going to hear here? Sound. Sound also is energy. So, what do you understand? That when you put here a 10 joule of work, we know that work is the same as energy, okay? What will happen? Not all of the work will become output work. Some of the work or this energy will transfer to other form of energy, sound and heat energy by the pulley. So for example, if you put here 10 joules of work or energy, what will happen here? The pulley will take 1 joule as sound and heat energy. So the useful work that is here to raise the object will not be 10, it will be 9 joules. Why? Because of friction. So some of the energy transfer to heat and sound energy. Okay? So what is important here? To know where is the input work, where is the output work, where is the useful, where is the total. So total work, it's all the work. We put it on the machine. So where is it? For sure it is the input work here. Useful work is the work that is used to raise the object. So here, the useful work will be the work that will be here, output work. Okay, good. So let's see here, because of friction, some of the energy applied to the pulley to lift an object is transferred as heat that warms the pulley. This warming is not a desired effect, for sure we don't want. That's why always we try to oil these objects or these machines to reduce friction. Okay, so to reduce the amount of energy lost by friction.